eventually, I think this actually came from Jason when he was in Florida. Jason said, hey, listen, we have this nice little actuator with a 0-90 degrees rotation, right? And we have this nice little ball valve, which just happens to open, you know, somewhere between 0 and 90 degrees. What would happen if we take this ball valve and couple it with this actuator? Boom. That's how the motorized ball valve actually started.
In addition to the innovation of the ball valve, Neptronics also introduced the first capacitor spring return, electronic spring return.
That is correct. The whole idea came from the fact that we actually are an electronic company, right? So we decided that why not put the electronics inside of the actuator in order to, you know, have a certain mechanism to make it fail safe. So instead of using a mechanical spring, which is typically what everybody else pretty much is using, we actually decided to put a capacitor. So we would load it up with energy and have it stocked with energy, and whenever there's a power failure, then use that energy that's been stocked, that's in those reservoirs called capacitors, and drain that energy out so we can fail safe close or open the actuator or the valve. That's basically the whole idea.
Listen, I'm very impressed. Quite a facility, quite a story with Neptronics introducing the ball valve, introducing the capacitor. Now, tell us about this.
Well, this actually has to do with our family of humidifiers. What we did is that we started thinking about direct steam humidifiers. And one of the major problems we have with direct steam humidifiers is the fact that they generate a lot of condensate, because it's just the nature of the beast. And what we decided to do is that we said, hey, how can we work something out or come up with some type of product that instead of draining and throwing away all this condensate that is generated through a humidifier system, how can we actually use it instead and not throw it away? So what we decided to do is to actually put a reboiler underneath our direct steam humidifier, so that every time we're generating condensate, instead of throwing it out, we're actually reboiling it and therefore flashing it back and sending it back into the airstream.
Very nice.
So basically there's zero. Direct steam humidifier, what you have is actually you have steam coming into the manifold, and therefore then turning and going into the different steam channels, and from there basically being thrown into the airstream. The problem with that, if you notice, is that this one here is not insulated. Therefore you have steam coming out at 212 degrees atmospheric temperature, hitting air at 55 degrees, and obviously what happens is that we generate condensate. And once condensate is generated, well, this steam transforms itself into a liquid state it actually becomes liquid. And as it falls down, instead of draining it out and throwing it away, what we're actually doing is with that, we're reusing this boiler underneath, who's under high pressure steam. And by doing that, we actually have a temperature of 240 degrees. So you have condensate falling at 210, hitting this very hot media at 240 degrees. So what happens? That condensate flashes and is rethrown into the airstream. And this is exactly the SKD, which is with the reboiler, and this is the product that helped us win the Innovation Award this year at the ASHRAE Show.
This is what's happening, okay? With this type of actuator, let's say that, here we go. Right. Okay, this is what you have on the job site, right? Right. So if ever you want to install it, you can always install the valve, give it to the plumber, right, and then take off. Gotcha. And then come back with your little valve, right? And the only thing you need to do at this point is basically just to take the head of the actuator, right, and just install it back into
and
the phone valve.
And that's your you have two position, and you also have 0-10.
That is correct. Correct. But the other advantage to it is the fact that, let's say for a reason or another, you need to override this valve. Okay?
Right.
I'm just going to put it back on. You need to override it. Now your valve is overrated.
Okay,
it's open or it's closed without powering up.